man, you can't ride horses indoors in this game. All right, so you've got your new system together, and once you get Windows up and running, right, some of this is absolutely warranted. You got to try out a few of your favorite games to see how they're running. But how do you know your Ryzen system is running at its absolute best? Well, today I'm going to share a couple of setup tips with you so you get the most out of your system. Then you can go back and goof off again. Well, welcome to Machines and More. Recently on the channel we did this build in the NR200P with Ryzen 5 5600X and the RTX 3080. And maybe you've done a similar build or you've already done a build in the NR200. Wow. Well, today I'm going to share a couple tips. We'll cover fan curves, dialing in your CPU. We'll look at the GPU primarily and how you might overclock or undervolt it. And then I'll show you just some utilities that you might want to download to benchmark and also controlling the lighting in your system. I'm going to start this guide from the perspective that you've already gotten Windows installed and you have some of your games on there, all the driver updates, everything is ready to go, and then we'll take it from there. So to start, we're going to set our system right into BIOS. The first thing I would recommend nailing down is how fast you want to run your case fans. In the Gigabyte BIOS, it's pretty simple. Once you get in, you'll just hit F6, and you can also access it from the menu bar over here in Smart Fan. You'll see it will take you to CPU fan first. Let's go to SysFan 1. Let's set up our case fans. Select this drop down, and you'll be confronted with this curve. This is your default fan curve. Now there is a good reason to run case fans harder if your system is working harder, but actually for the most part you can keep it simple from a noise and performance perspective. Just run it at something that your ears feel comfortable at most of the time. That way you have less ramping up and down. There's more noise that you're actually sensitive to because it's changing. So what we'll do is switch to manual in the drop down, and then we'll just drag the sliders so that they fall into a flat line. There is a fan speed readout, and so it'll correspond to the current temperature. So what we'll do is drag this all the way across, and we'll try to make it a flat line slowly, because right around 40% is where I would have these. Just and then you want to eyeball the RPM. So if your fans have if you went with different fans, you'll have a different RPM at each PWM setting. So 40% on this gets you about 1,000, 1050 or so. So we can go a little bit lower. Start here, say, let's see what 36 gets us to. So that's round about where I'd want it. The fans are pretty quiet at 1,000. If you think it's too loud, you can also lower it down even more. But I think this is a good starting point. You can always change it. So for the most part, this auto is fine. You can also set it on PWM if you really want. There's no good reason to. It doesn't change the RPM. And everything else we can just leave as stock. Once that's dialed in, let's discuss the CPU fan curve. So this one is completely dependent on your particular CPU cooler, or if you're running an AIO. If you're running a fan with really high max fan RPMs, you might choose to lower this curve a little bit. But I'm setting this up from the perspective of this Kaze Flex fan on the Mugen 5, which this one tops out at 1200 RPM. So from a performance perspective, you almost have to have it running at max when it's at about 70 degrees, because it's only 1200 RPM. You only hit this level at more serious loads, so just listen to your CPU fan and make sure you're comfortable with whatever that maximum level is. I don't think this particular fan is very loud, and some airflow is always healthy, so I would kind of go 40% at about 40 degrees or so, which is where Ryzen will usually idle at. So we can bring it over here and 40, and from here we can set a pretty steep curve just because this particular fan is such a low RPM. All right, so this is one way you might set up this fan. If your fan spins up to something like 2000, then you might want to have that max out like over here at 80 or 90, depending on what your tolerance is, and then your curve will look a little more flat like this. All right, and if your fan's really loud and you don't want it running so loud the whole time, then you can just drop down this curve a lot more. You can raise the temperature, you know, you can make it hit max a lot later if that's how you want to run. I typically wouldn't recommend this steep of a jump up at the end, but this part is really up to your ears and what temperature that you would want the system to run at. Something set up like this will tend to run hotter and then ramp up to save itself later on. All right. But we'll go back and I'll just set this up to how it was earlier. We'll click out of this. You can just hit escape, or you can click here. And then what we'll do is set up our memory now. So we'll have to go to advanced mode for that. Hit F2 or click the button. And under this tweaker tab, you'll see extreme memory profile, or XMP. All right, now select XMP to be active. Now this is assuming you've made sure your memory is running properly after you installed Windows. And you'll just pick the default, the profile 1. So when you're a little more familiar with your system, you can tighten up the memory timings, which really helps with Ryzen, but this is a quick way to get a big benefit. Most memory modules are specified with a base timing and this other one that's called XMP. So if you select XMP to be active, you're using the default XMP timing that's specified on your RAM kit, and that is a tested profile from the RAM manufacturer, so that is a perfectly safe place to be. If you check in overclocking, you'll see Precision Boost Overdrive is already set to be auto, and we'll test how that's working shortly. If you want to dial in a permanent undervolt or overclock, you would do that in BIOS too, and under manual CPU overclocking. But for the most part, I don't think you should be doing that yet. If you do want to set that up, get to know your system a little bit better, and make those adjustments later. So we'll click Save and Exit, and we'll just let the system reboot. And you'll double check everything is set up according to what you want. So those are the things we changed, right? XMP, we changed the speed control on the CPU and the case fans. So with your fan curves and initial XMP setup, we can go back into the system. I'll talk through some of the utilities you might want to download to help us figure out how the system is working and get some optimizations. The most important utility for any Ryzen system is Ryzen Master. This is AMD's own utility to tune the CPU and get an idea of how things are performing on each core. And Ryzen Master will give you a quick readout of all the vital CPU parameters. You can even do a little overclocking or undervolting in here. For the most part, for right now, we will be doing some of the optimizations in BIOS because they're not available in Ryzen Master yet. But this is a very convenient utility for your system. The other one is just to get a general hardware monitor. I like CPUID's HWMonitor. This is a free utility for the basic version, and it will give you everything, pretty much everything in your system that you can get a readout on. Fan speeds, voltages, your GPU temperatures, your temperature sensors, the power utilization, your RAM parameters, your hard drive temps, all that good stuff. Cinebench. This is a quick, this R20 version is a quick AVX workload that will kind of give us some quick thermal and voltage readings and see how fast our clock frequencies are at. Next is MSI Afterburner. This is primarily a GPU utility. We'll use this to tune the GPU later on. It will help us to adjust the fan curves, adjust the clocks. We can lift the power limits. You can do a little overclocking in here as well. For the stress test on the GPU, we'll use Unigine Heaven 4.0. This is just a continuously running benchmark. There is an internal benchmark function where you can get a score, but we'll just be using this to keep the GPU running so we get an idea of how it's responding to each adjustment that we make. For actual benchmarking, we'll be using Unigine Superposition. I like this utility for for benchmarking a little bit better than Heaven 4.0. And so we'll use this to test our overclocks and our undervolts. So if you go and download Cinebench right now, most likely you'll get the R23 version. This is non-AVX, so it'll result in a little less CPU heat from what I understand. You can use this or you can use the R20 version. Both are perfectly fine. I'll use R20 because I'm used to it. Let's just fire it up and get a baseline. Also have your HWMonitor running, or Ryzen master, because we're going to take a look at the voltages for the CPU and also the clocks that the system is boosting to. Okay. So let's just hit run. And I do have OBS running in the background, so that might affect kind of the scores that we're seeing here. But your system, whatever you do, just start from the baseline to get the estimate, and then with each adjustment that we make, well, that's what you'll reference to. So regardless of whatever score comes up here, we'll just use that as our starting point. This is the CPU at stock. In fact, with the latest BIOS, the temperature is very, very gentle. And if we look here, the amount of power the CPU is getting on stock is pretty low, well less than 65 watts. The cores, we're boosting to about 4,300, not anywhere near the 4,600 that I would expect to get. So what we'll do is, once we get this baseline, we'll adjust things in BIOS a little bit. In terms of voltage, we're only seeing about 1.2 volts or so. In the HWMonitor here in Ryzen Master, seeing 1.21, so roughly around 1.2 volts. That's a very gentle amount of voltage that the CPU is getting. So we finished up our multi-core render. Score is about 4,000 for the multi-core. Single-core 591, pretty good, but let's see if we can give the chip a little more juice. One other option is that you can set an all-core frequency lock with a defined voltage, and I'll show you how to do that later. And then you can just activate that profile if needed. But let's go back into BIOS and see what the new PBO is capable of doing. So we're back in BIOS and we're going to tune our PBO a little bit. This is the new PBO on the latest BIOS F11N from Gigabyte. So it will include a curve optimizer. I'll show you that real quick. It gives you a disclaimer. Basically, if you screw up your CPU, it's your own fault. So yeah, do take some caution. Although PBO is in general fairly safe to use. So click on Precision Boost Overdrive. By default, it's on auto. We can tune it a little bit better to get more performance in CPU renders and games that are more CPU limited than GPU limited. So higher FPS games, if you're playing at 1080p, this is going to be helpful. For 1440p and 4K gaming, it's really not going to matter that much at all. I've gone ahead and set up an example profile to start. This is PBO limits manual. I've just gone ahead and keyed, and these are fairly stock numbers. The 5600X isn't going to go anywhere near these. TDC is the sustained current, EDC is the peak current. This is really a non-issue. You could even leave it on auto if you wanted. I set this Precision Boost Overdrive scaler to manual 1x, and for games that can really benefit from single core performance, this is where you're going to see this boost clock override help, because this is theoretically telling your CPU to boost above the stock max boost frequency. It's not going to do anything for all core workloads in general. I don't expect it to push past 4600 megahertz much. But where we really want to play with is the curve optimizer. And this is essentially an overvolt or undervolt setting. The latest BIOS and PBO is running the CPU fairly conservatively. It's giving it very, very little voltage and is running it very cool. You saw the Cinebench only hit about 4,000 and the voltage was somewhere like 1.25 or so. So this footnote is saying, okay, if you give a positive offset, you're going to see higher voltages. If you give a negative offset, you're going to see lower voltages. That was not what I saw. What I saw was that if you gave it a negative offset, it was giving it more voltage, and positive values were an undervolt. In general, with how low the voltage was running, I wouldn't give it any less voltage than stock, except for the better cores. So in Ryzen Master, we were able to identify Core 2 and Core 6 as the better cores. So those I feel comfortable undervolting just a little bit. So here I've set a positive offset for those two, just a little bit here. And for the other ones, I've gone ahead and added a little more juice. So 15, 15, 15, 15 here. So that should allow the cores that need the voltage to get it, and the cores that are better can run with lower voltage and still hit the same frequencies. So we'll try this out. The other thing you can do if you don't want to mess with that much detail is just go to all cores, and you can set a negative offset of like 15 or 10 for everything. That is going to give your system more voltage, especially on those good cores, but you know, this is going to require some trial and error anyways. We'll just use this and we'll go back in and we'll try things again. So hit save and exit and go back into Windows. So we'll get back in here and just run that multi-core test again to see how things are shaping up. Compared to stock, you'll see after setting that offset, thermals are going to be higher. Power usage is increasing. That's what I was saying, that negative offset seems to be a voltage increase. Core frequency is up about 45, 50. This chip, as I've tested it, is capable of a little more, but under PBO, it's really not going to drive it to the wall. The best way to do that is still to set a fixed all-core frequency in Ryzen Master and then activate it when needed. And the rest of the time, just keep it on something you feel comfortable with, because that will kind of make the system run cooler. The cores will go to sleep if they're not being used. So 4319, we can also do the single core test to see how things shape up. And I am running OBS in the background, so your results may be higher when the background processes are eliminated. But just to give you an example of the performance change. So I reran all the tests. I did the multi-core and the single core again. The single core, you can see, got a good bump up above 600. So I'd say that's good enough for a 4K or 1440p gaming system. For 1080p, you could tweak it further. I'm not convinced that there's too much more performance to be gained from this. I mean, for a single core, the chip is getting pushed pretty hard already, like at 1.4 volts. For multi-core workloads, just tweaking a little bit in Curve Optimizer can get you a lot of extra performance, so I definitely recommend that. But next, let's take a look at locking down a fixed all-core profile if you want to take things further. If you do some CPU rendering, you might want to create a profile in Ryzen Master so that you can apply it if needed and force the CPU to max boost clocks. We can just select one of the new profiles here and then click Manual, and we'll click, you'll usually have to expand this here and click this guy. And let's just start at the max boost clock. So that's 4600 megahertz, which is we're just locking it down. And what we can do, and you definitely don't want to start with a peak core voltage here. It's saying 1.206, so that's gonna be way too low. And what we were testing at just now was 1.3. The system was giving the chip 1.35 to 1.375 based on our baseline test. So we can just set 1.35 to start. And for the most part, that's all you'll have to do. Just hit apply, and you've locked the core frequencies and the voltage. So what we'll do is just run this again and kind of compare against our previous baseline to see if we're getting a meaningful boost or if it's just for entertainment only. If this voltage is lower than what your motherboard would usually feed the chip, that your CPU run a little bit cooler, and you're guaranteeing that the chips will hit that max boost clock for whatever rendering that you're doing. Now this is completely optional, and I am pretty sure that for just like Ryzen 3000, for Ryzen 5000, any gains you'll see from doing this are fairly meager. And for most people, it's not really worth tweaking yet. Zen and Zen Plus was very different. Where overclocking something like the 2600 or the 2700X would, is provided you had above average silicon, would actually yield some meaningful gains. But if you want to create a profile like this for your system, then you just find out a good starting point and then lower it 25 millivolts at a time until Cinebench crashes. Now, I've kind of done the testing beforehand, and I kind of know where it's going to sit, so I'll just show you what it might look like if it crashes. Okay, so that did it. You'll see it says, it'll give you this kind of error message. That basically means you went too low. Just keep it there. For this one, I actually would set 1.35. And then this profile you can save and call whatever you want. What you will do is that you just let your system run on stock, and then if you're getting ready to run a render, you just hit, go to this profile and then hit apply. So that's how I would do that. All right, so by far in an SFF system, the bigger thing to optimize is the GPU, because that is a huge source of heat. So what we're going to do now is dial in the RTX 3080 video card, and the process will be mostly the same with other cards, though the frequencies and the voltages discussed here won't be the same. Load MSI Afterburner here, and this is basically a utility that will allow you to tweak your GPU fan curves. You can tell the fans to go, oh, let's try 100%, and you'll hear that fan, totally ramp up. But for the most part, we can leave it at auto for right now. And the other thing it can do is allow you to play with your power limits, your core clocks, your memory clocks. Will also be a good idea when you're installing this to install the Riva Statistics Tuner. You can access that here in the monitoring. So this will actually give you an overlay when you're playing games or doing benchmarks, so you can get some vital system statistics on hand. Pretty simple. For tuning the GPU, we'll just go ahead. Let's fire up Unigine Heaven 4.0. And you can choose whatever settings you want. It doesn't really matter unless you're actually benchmarking and try to compare it to someone else's score. But we just want to fire it up and get an idea of where things stand in terms of your core clocks. So this will help us figure out how much of an overclock we can do. We can also do, just to figure out how much of an undervolt we can do as well. So what we'll do is warm things up a little bit. So we'll come back in 10 minutes. We'll just let things settle in. Now we've warmed up things a little bit. We just want to see how things are looking at a steady state. Note your GPU temps and your general core frequencies. So here with the Afterburner overlay, we're seeing about 70 degrees or so, and the GPU boost is hitting about 1860, 1870 megahertz, 1850. So that's going to be our starting point for any overclocking or undervolting that we do. So when things are warmed up, you can go ahead and just shut down Unigine 4.0. And then what I'll do is open up Superposition, and I'll run that at 4K optimized. So we're running this to give us an idea of what the baseline score is when our GPU is warm. And then we'll go ahead and try a few things, see if we can get things to perform at least the same while lowering the voltage, or be able to increase things a little bit and overclock it slightly. For the most part, the FE cards will boost up to above what Nvidia specs to boost at. So 1800, 1845, that's kind of where we expect things to get to when things are warm. So from that point, we can either overclock or undervolt. If you really want to squeeze every FPS out of the card, then overclocking is a good idea. The process will be similar between overclocking and undervolting, but let's try overclocking first, because That gives us an idea of what the card is capable of. And that will also tell us how well this particular card will undervolt. So the benchmark wrapped up. We're at about 14,100. And what I was noting is that the GPU was hitting about, it still stayed about 70 degrees and 1850 or so. So let's try the overclocking first. So with that baseline, we'll go ahead and try to see how much we can push this card. So we'll just lift all, we'll increase our power limits to the max that your slider will allow. And you can use this slider to adjust the core clocks as needed. It's probably easier just to type in 50, 50 at a time. So what we'll do is we'll fire up Unigine Heaven again, and then we'll have Afterburner running in the foreground here. And what we want to do is just see, kind of toggle things and see at which point we can get it to crash. So we'll increase it another 50 megahertz and click check. Let's keep an eye out and see how things are running. This still looks pretty good, then we'll dial it up. At this point, you might try 25 megahertz increments. Got 150. Oh, and that tells us that we've kind of gone too far. Okay, so it looked like 150 was where we should stop. So we'll leave it at 150. We'll fire up Superposition again and see where we end up, if it's higher than before. So we're just finishing up our benchmark. You'll notice the card's gonna run hotter. We've lifted the power limits. It's also running faster. So we'll see how much of a performance uplift we get from this overclock. And you'll see that score went up fairly significantly. So if you're at a point where you feel like things are stable in Unigine and Superposition, then you can proceed to run some games to see how that overclock is. Okay, so 150 gave us a good performance uplift. We can fire up Heaven 4.0 again. And then now what we'll do is we'll play with VRAM clocks. So this one, I'd go 100 megahertz at a time. And we'll do the same thing. What you're looking for is any artifacting that might appear. Stuttering is also not good. So if things look smooth, you can keep bumping it up. I'm just going to go a little bit higher than what I know this card is capable of, just to show you what that might look like. So this one just flat out is not running at this point, right? So that's how you know you've gone too far, so just back it off a little bit. And then see if things will stabilize a little bit. So if that's still stuttering, then what I do is just lower it a little more. It's a little bit better, but it's still hanging every now and then. So we'll try 350 on this one. That looks a lot better. So we'll go ahead and just close this out, and we'll fire up Superposition again, just to get a final benchmark. So that crashed. I'm just gonna go down a little bit more. You just wanna incrementally try things until you find the point at which you pass everything. So this benchmark is rapid. You kind of see the VRAM is running 9800, GPU is running 1965 megahertz or so. So this is all higher than before. You'll see a little bit of a bump up, but not too much from overclocking the memory. But for the most part, 15,000-ish, that's a decent overclocked score for 3080s. And I've gotten this higher, but it does involve giving it a lot more cooling. So if you want to run that fan super loud and like at 90% and see if you get a much better score, you will. That's one way to play around with it. But by far, the bigger advantage for an SFF system is undervolting. Overclocking is asking it to run faster. Undervolting, if we're able to overclock a little bit, we can also give it less power and run it at those stock boost frequencies, like the 1800s or so. So to undervolt, we'll kind of follow the same process and find out how low we can go. And if you want, you can save this overclock as a profile. So I'm just going to pick 3. But to undervolt, we'll reset everything. Let's fire up MSI Afterburner. We'll hit Control F to bring up the voltage slider. So what's going to happen now is we saw that we can run typically the GPU boosts up to about 1845. So we'll find the point corresponding to 1845, and you'll see right here it's about 956 millivolts. To do this, we'll just hit Alt, and you can lower everything. Hit Alt and lower everything down minus 150. So we'll just go over here, that 870 or so. And we'll bring this up to that 1850 point. And here we'll also go up to 1850. It's about there already. So 1850. And what we'll do is just click check. And we'll check it one more time. So we were expecting 1850, about 875. So that's good for the first run. So we'll go ahead and fire up Unigine again. And just take a look at how things are going. So 18, we're now lower than before. So we're still hitting about 1800-ish megahertz. But now what we're doing is we're running at a lower voltage. So you can incrementally do this. You can lower it even more. You can go down to minus 200 and push things down a bit again. So what happens when we go too far? Let's take a look here. Just say we only want to run 800 millivolts. I want to tell it to go all the way up still to 1850. See what that might look like. Ooh, not so good, right? So I don't think that's looking good. So let's undo that. I found that you can run about that 850 millivolt mark, and at the normal boost clock about 1850 seems to be a safe place to be. So once you've got that dialed in, it'll take a little bit of trial and error to see how low you can go. I'd say drag the general curve down about as much as you can overclock, maybe a little more. And then just find that point, probably 100 millivolts or so is a good place to be to undervolt. And then when you're all done, just save a new profile. and that'll be your undervolt profile. What we can do at this point is kind of compare the thermals and also compare how the power consumption. To do that, we can go into powers. We'll go to GPU powers. And you'll see right here, it's hovering at around 250, 260 watts, which is a huge savings, because if you look here, and if I reset it, and you come back in here and you see, oh, it's jumped back up to about 318, 320 watts, right? So that's the stock wattage. But once we apply our undervolt, you know, the GPU, not only is it going to run cooler, you get to save a little bit on power consumption too. So in general, for any system where you really don't need this GPU boosting that far high up to like, you know, 1900, 2000 megahertz like we were doing earlier, this is a good way. So we can close this out. What I would do at this point is just run superposition again one last time. And you can see we've basically pegged the core frequency at that 1845 megahertz. And what we're looking for primarily is that the performance didn't change. So as long as that's the case and we're getting right around the same score, then we know we're not taking a performance hit, and you know, that's well within range of what we're at, maybe a little higher actually. And so that looks pretty good to me. At this point, what I would do is just fire up some games and see if the games that you're playing is stable, because that's the real litmus test, right? If not, I would just bump up voltage a little bit at a time, maybe plus 50 millivolts or so, just to get things running stable. Just to give you an idea of the starting point, kind of around mid 70s here for the Assassin's Creed Valhalla benchmark at 1440p. The CPU is posting up to boosting up to 4650 megahertz or so, which is a pretty good boost clock to be at, considering how cool it's running at. About 60 degrees. The new BIOS is really gentle on CPU voltages, and I do like that a lot. So I'm going to let this run and see where things end up, and then I'll compare it to the fully optimized system. So with the benchmark finished, the starting point 79 average, min of 48, max of 146. What we really care about this low, 1% low, 59 FPS. So 79 average, 59. So we'll see if our optimized system with an undervolted GPU and an optimized CPU can beat these numbers. GPU temps were hovering around 70 degrees or so, and the CPU about 60 degrees. So once you've gotten things to where it's running well, you can push this even more. You can drag things down a little bit more. We did minus 150 before. We can go just a little more. Maybe try minus 170 or so. And then we'll just go to here and see if we can't still hit the same clocks. Okay. Just up one little bit. So we're just going through our final optimized benchmark run here. In general, with a GPU limited resolution or title, you're not going to see too much of a bump up from adjusting PBO. The system will give the CPU as much as it needs. But really, from undervolting this GPU, we're able to keep the same clock frequencies as in the benchmark, the first benchmark run. But if you look at that GPU temperature, we're 6-7 degrees cooler than before, and that means that the fan can run at a lot lower speed and be a lot more quiet. When there is a CPU limit, though, that's when if you're playing at 1080 or an older title where that CPU is going to be higher utilized. I mean, it's only about 40% utilized here, so that's really not challenging it at all. But when you do have a CPU limit, those PBO adjustments will come in pretty handy. And you saw just with that Cinebench benchmark, we could gain about a few percent just by tweaking PBO. So these are the results from the final benchmark run. 79 FPS still, not too much of a surprise there because we kept the GPU to the same boost frequencies. Low 1%, about 60 FPS, around about the same 59 as 59 we saw at the beginning. But the huge benefit was how quiet the GPU can run now with that about 6-7 degree benefit of lower thermals. So all in all, if you do play at higher resolution, you will see more of a benefit from the CPU tuning, but the undervolting is where I really would focus my attention on for a 1440p or 4K SFF gaming system. The other thing that might be helpful is if you want to change the fan settings. So you can click fan in the settings and enable user-defined fan speed control. So if you don't like the fan curve, if you think it's too loud or whatever, then you can lower these curves down. Of course, your temperatures are going to be impacted, right? So the last thing that you might want to do is if you have RGB fans and RAM like the demo system was built up with, you might want a utility to tune it. Here I'm using the motherboard, Gigabyte motherboard's RGB Fusion software, but each brand has a specific utility if it's RGB compatible. So since all the fans are connected to the addressable or DRGB header, we can select that. You can play around with different settings. We'll just click into this digital LED here. And right now I like to have it on a static if I have lighting just to show the viewers what's going on inside the case. But what you can also do is if you want some more fancy effects, you can click like a color cycle where it will, go through different colors, or digital wave, which kind of looks like a whole bunch of different things at the same time. So lots of different settings you can play around with. You can even adjust your RAM's color if you want. So now go enjoy your system. Run a few games, make sure everything is stable. If not, tweak it a little bit. I'm gonna pick up where I left off in this game, and I guess I can't ride horses indoors, but I hope you're enjoying the system that you built up, whatever it is, and I hope you found this guide helpful. If you have any additional setup tips that you'd like to share with our viewers, I'd love to hear it too. I'm sure the community would also appreciate that. So feel free to share down in the comments below so everyone can see. And also please consider subscribing to the channel if you haven't already so you can get all the updates on new content. A huge thanks for watching today, and I'll see you in the next video.